Now, first case, we will talk about the transportation problem. What's going on in reality is that we have several points of which we want to obtain supplies from. Those supplies are going to go from one point to multiple other points. We call the places that we are supplying from sources, and the places that require demand, we call them destinations. When we look between our sources and our destination, we're going to be given a capacity that is capable of being transported along that route. On one side, we're going to be given our supplies, and the other side, we're going to be given our demand. And in this case, our goal is to minimize cost. So let's look at an example to show our point. In this case, we have our supplier, which supplies desks from 3 locations: Des Moines, Evansville, and Fort Lauderdale. And from these 3 locations, we are sending them to warehouse, which is our demand function, in Boston, Albuquerque, and Cleveland. Here's what it looks like. As you can see on the left-hand side, we have our sources. These are our factories. These are where our supplies are being made. And then on the right-hand side, we see the demand. So along the routes, we can transport from any one of 3 of our suppliers to any one of 3 of our destinations. So as you can see, we have linkages between our three supply sources and our 3 destination sources, along with the supply and the demand. If you look along the routes between our supply and our demand, you'll see the cost that it takes to get there. These costs will be what we will look at as our objective function. So for example, we want to minimize the cost between Des Moines and Albuquerque, Des Moines and Boston, Des Moines and Cleveland, and at the same time, we want to add in Evansville and Albuquerque, Evansville and Boston, Fort Lauderdale and Cleveland. So, what is our general linear programming model for transportation problems? So, don't get hung up on the symbology. Here, we're saying that we're going to let each one of our connectors have an I component and a J component. For example, if I let Des Moines be my first component for supply and Albuquerque be my first component for demand, then this would be X sub 1, 1. Okay. Now, we also have a cost associated with going from our source to our destination, and we have how much we have at our supply, and we have how much we have at our destination, or what our demand function is. Here's what it looks like. Here's our formulation. We want to minimize the cost. In other words, we're going to take each cost value associated with going between each of the cities and add them together. That's all this is saying. Take each one of my costs along each route between the cities. And as you noted, we had 9 routes between the cities. And then we have our supply function and we have our demand function. Okay. And then, of course, as usual, we have our non-negativity constraint. So here's what it looks like. And in this case, we're going to let Des Moines be our I's 1 and Albuquerque be our J1 and so forth and so on. So we're going to give them a designation. All right. So when we put it in the model, as you can see, we're going to have 9 different routes that we have to optimize. So the route between Des Moines and Albuquerque costs $5 to ship a desk. Whereas the route between Fort Lauderdale, which is 3, and Albuquerque, which is a destination 1, 3-1, is $9 per desk. Okay, and that makes sense because there's a greater distance between Fort Lauderdale and Albuquerque than any of the other 2 cities. So here's our objective function. We want to minimize the cost along each one of these routes. Subject to, well, here we have our function, our supply function for Des Moines and our supply function for Evansville and so forth and so on. Our demand function for Albuquerque, Boston, and Cleveland. So whatever we ship from Des Moines to Albuquerque, Boston, and Cleveland, the most we can ship is 100. Whereas with Boston, the most that we can ship, the demand for Boston, the most that we can ship is 200, or the most that they can receive is 200, because this is what the demand is. Okay, so as we continue this operation, we go to our QM for Excel. And in our QM for Excel, we're going to click on our menu for QM. Once we click on QM, we're going to get the menu. And then we're going to look at transportation problems right now. But eventually, we're going to look at assignments problems, and we're going to look at waiting line problems. So we're going to be able to use QM for Excel to solve our problems. Okay, so we're going to select transportation. And when we select the transportation problem, we're going to get this screen. So let me enlarge it for you. So with this dialog box, we're going to enter the number of origins. We're going to name it. First, we got to name it our title and our sheet name. We're going to enter, we have 3 points of origins and we have 3 destinations. And of course, we got to select minimize. And then we're going to select OK. Once we select OK, we will get this screen right here. And we're going to input our information. So here's what we know. We know that destination 1, and our origin. Well, we know that our origin is Des Moines, and our first destination is Albuquerque. And it costs us $5 to ship. From Des Moines to Boston costs us $4. And from Des Moines to Cleveland costs us $3. And we have a total supply of 100. And we do the same with our other cities, Evansville and Fort Lauderdale. And we also have our supply. And then along the bottoms, we know that for Albuquerque, our demand is 300. For Boston, our demand is 200. And for Cleveland, our demand is 200. So as you can see, we have a total supply of 700 and a total demand of 700. So we input this model, and now we're ready to compute using the solver to get our answer. So if we click here on data, our solver menu will come up, and we're going to select solver. And once we select solver, this is what we will get. So with our box here, the only thing we have to do is all our information is given to us, and we're just going to select solve. Once we select solve, we want to select answer, click on answer, and it will turn blue, and then we want to hit OK. And once we do that, here's what will happen. Along the bottom of our Excel spreadsheet, we'll see a tab that says Answer Report 1. And as you continue to do this, and if you use the same spreadsheet, then you'll get Answer Report 2, Answer Report 3. So it doesn't designate it as the Executive Furniture Corporation. It only gives you Answer Report 1, 2, or whatever you may have. So we're going to go down to the bottom, and we're going to click on Answer Report 1. And here is our answer. And so, well, what does our answer tell us? Our answer tells us that what we're going to ship is that we're going to ship 100 desks from Des Moines to Albuquerque. We're going to ship 200 desks from Evansville to Boston, and 100 desks from Evansville to Cleveland. And from Fort Lauderdale, we're going to ship 200 to Albuquerque, and we're going to ship 100 to Cleveland. So our supply meets our demand. Our supply has to meet our demand, and the total cost that we have is $3,900. Well, how does that break out? Well, here's how that breaks out. So I'm shipping 100 units from Des Moines to Albuquerque. The cost is $5 times $100 is $500. And I can do that for each one of my shipping points that is the optimal shipping point that's going to minimize costs. And then if I add them up, I'm going to get 3,900. So that's the basics. And now I leave it up to you to play with it.